Hi everyone, this is my lab 5 for Physics 2211, and this is basically a choose your own adventure lab. So in this lab, I'm going to be examining an object that's going to be undergoing parabolic motion, and we're going to look at it from the top of its arc and make a model in order to predict the motion of the object. So first we're going to define what parabolic motion is. So parabolic motion is similar to when you throw something underhanded, it's going to make that parabola or that upside down U shape. So it has a motion in two directions. At least in this lab, it's going to have motion in the x direction because it's going to go forward, and in the y direction. So this happens because the force is initially pushing it upward, which causes it moves against the force of gravity. However, the force of gravity is eventually the only thing acting on it, causing it to come back down, making that U shape because it's still moving in the x. So we're gonna look at my video really quickly. All right, here's the video, and there's the pair of earmuffs at the top of the arc. And as you can see, it goes down. Now, if you look at the chart, you'll see that the x moves at a straight line, while the y makes this curve going down. This is because the x moves kind of at an almost constant velocity because there's almost no force, there's no real force acting on it. However, this has the force of gravity and, of course, the drag force acting on it. So now we'll look at a few assumptions. All right, so before we actually go to the model, there's going to be a few things that we need to know. One, we need to know that the only things acting in the y direction are the drag force and gravity. So the second thing is that the coefficient of drag for this specific object is going to be roughly 0.1065. We're also going to assume there's no force acting in the x direction, so the x velocity is like mostly constant. The mass of the earmuffs is 0.07 kilograms, about 70 grams, which I looked up online. So we're going to assume the manufacturer was accurate. Now, the code for this lab is very similar to the code for lab 2. It's basically going to be a falling object with an x direction. So we have that the velocity vector is going to be the velocity in the x direction, which was roughly 1.64 meters per second, and 0. Now, the reason why it's 0 because is that at the top of the arc for a parabolic motion, we're assuming that in the y direction the velocity is 0 because that's the moment where it's going to change direction. Now, if we go down to our loop, we're only acting for that half, which is about 0.5 seconds. Now, if you look here, what's different is we have the weight force and the drag force only acting in the y direction. Now, they're already in vectors only acting the y because we don't want them touching the x because, it's constant. And if we run it, we realize that we have an Excel file open that I should probably close. Okay, now if we run it, we get this nice little motion, which is very similar. Now we're actually going to compare what happens on the x and y directions. So let's move over here. So I've already graphed these. This is the graph of the x direction, and as you can see, the orange, which is the model, covers almost all of the position. You can see a little bump right there where it outcovers. And this is true because basically the x direction, the velocity is going to be constant. So we know that holds true. But here on the y, we have it that right in the middle is where it's not really the same. So the initial velocity was 0. So this part should be right because we set our initial conditions. It should be right here. And then it should be right here because our drag forces made it so it gets to the same position there. However, the middle was not accounted for when we did it, so there's other factors that may be affecting it, especially since we used the most simplistic version possible in order to calculate the drag force. So our drag force could have been better calculated here to make the model more accurate. There's a few things we also know. We also know that the energy principle will also be satisfied in this situation because it's going to keep going down. The kinetic energy is going to be increasing because the velocity in the y direction is going to be increasing, and the potential energy is decreasing because it's getting closer and closer to the Earth. So yeah, so there's the model, and hope you guys had a great time.